Alright, good morning folks. This is going to be your work for today. We're going to start looking at equations, okay? We're going to go through one of these explanation grids for a start, just to remind you what an equation is. The way I would put a definition of an equation is it's an algebraic form. A pen that works. It's an algebraic form where you always have one unknown, but it also has equal sides, and that's the important thing. We often hear the word said, "Oh, an equation is something where both sides are equal." Well, it's sort of true, but it doesn't necessarily define what an equation is. It has to be of algebraic form, and the idea is it always has to have an equal sign, and that, is the one that most people remember. Try that down there, equals sign. But the bit that people forget is it has this algebraic form. Now, it can be any letter. Okay, doesn't matter if it's an A, B, C, X, Y, or Z. Okay, and that will represent something you don't know. Now we call that an unknown. But there can only be one letter. Okay, and that's the key bit. Only one unknown or letter. And the idea is that this unknown will have a value, okay? And you're going to work out what that is. So when you think about examples of this, loads of things you could have. You could have 5a add 7 equals 9. And that would be an equation. The idea being you've got your equal sign, you've got a letter, an a, and the idea is you can find out what a is. You could have different letters, perhaps a letter appearing more than once. You could have 2x add 3 equals 5x minus 7. That would also be an equation, because the idea is there are ways that we can work out what x is in that case. You can even have something called quadratics, which have squares in them. We've spoken about squares, so 2x squared minus 3x minus 9 equals 2. That would be an equation as well. And sometimes you'll even see fractions there, so well, let we'll use p this time for argument's sake. So we'll have p plus 4 all over 9 equals 3p. That would be an equation as well. Not particularly nice one, but they're all examples of equations because they've all got the equal sign and they've all got one letter in them, or just one letter appearing, that we can find out what it is. Bits, and this is where people go wrong with what isn't an equation, more like what you'll see in science. So for example, if I just used x and y, so x add y equals, I don't know, 5, that, you think, oh, it's an equation, got an equal sign, but it's got two letters, x and y. Now, that's been different, that's called formula, we'll talk about those another time. But the idea is, I don't know what x is, and it's impossible to find it out because there's multiple solutions. If you don't have the equal sign, for example, so 3x squared add 9, again, that looks all right on its own, but no equal sign, that's just an expression. So we mentioned those before, not an equation. And this probably one is the hardest one for you, but if we spoke about 2 lots of x add 3 equals 2x add 6, you'd be like, okay, you've just got the one letter, x. It should be an equation, you've got an equal sign, but it's not actually. And the reason is, when we expand the brackets like we've been doing, that would give 2x add 6 on that side. So all you're basically saying in that case is 2x add 6 is equals 2x add 6. You wouldn't be able to find out what x was. So, examples of what we can do with equations. Before we even go on to solving them, we can do lots with equations. So the idea is like a balance. And if you think about it in this case, say 4x add 3 is equal to 22. All I'm asking you to do here is to add 2 to both sides of the equation. So if I just write an add 2 underneath both sides, in order to keep it balanced, we have to do the same thing to both sides. So 4x add 3, if we add 2 to it, gives us 4x add 5. That's not hard, we've been doing lots of stuff like that. 22 add 2, well, even easier, is 24. So what we're saying here is if we know one statement to be true, we can create another statement that is also true. And that's it. Let's not worry about trying to find out what x is at this moment in time. Let's just use our algebraic skills just to manipulate and mess around with them. So in this case, multiply both sides of the equation by 2. So this time I'm just going to put a little times 2 there. Okay, now this one here, we're going to multiply 4x add 3 by 2. Now we've been doing that again with our Expanding out brackets. I'm just going to write that for a start. So that's what 2 times 4x add 3 looks like, or 4x add 3 times 2. Again, 22 times 2 is fairly easy. That's just 44. So that would be your answer. That's okay. I've done it. I've times both sides by 2. If you want to expand the brackets like we've been doing, okay, let's do it. 2 lots of 4x are 8x. 2 lots of 3 are 6. So that equals 44. That's all I'm looking for. Okay, this next one here, add 2 to both sides of the equation now. All right, add 2. Let's have a look what we've got. We've got 8x add 5. I'm going to add 2 to it. So 8x doesn't get affected by the adding 2, but the 5 goes up, doesn't it? So plus 5 turns into plus 7. Nice and simple. 8x plus 7. What about the other side? 2x minus 9. We're going to add 2 to it. Well, the 2x doesn't get affected because we're not adding x's to it or doing anything with those. Minus 9, add 2. Yes, it's me going on about negative numbers again because that's always the bit that people muck up. Minus 9 add 2 would be minus 7. It's still negative. It's just gone up by 2. Okay, this next one here. What we're going to do now, rather than just add a number, we're going to add a number that's algebraic. So we're going to add 3x to both sides. I don't always write these bits, but we'll start off by doing it like this. So 8x add 5, we'll add 3x to it. Okay, so 8x add 3x gives me 11x. We're altering the x's, but we'll leave the numbers on their own alone. 2x add 3x will give me 5x. And the minus 9 will stay as it was. And that's it. Okay, this one here, we're going to subtract. Oh dear, take away. All right, so minus 4x, okay, to both sides. We'll put a little around it. So 5x, we'll take away 4x. So 5x take away 4x is 1x. We've spoken a lot about how do we write that. 1x, we'll just write x. The 8, well, the minus 8 doesn't get affected, stays as it is. 6, that stays as it is as well, we're not altering that. We're just taking away 4x from the minus x. So again, it's negative numbers. Minus x minus 4x will give us minus 5x. Okay, and there we go. So again, you're just seeing now this idea of an equation like a balance. If you do something to the left-hand side, you do it to the right-hand side, and you just basically do it to the bit that affects. This one here, we're multiplying again, multiplying by 3, okay? Let's see what that's going to come about. Again, remember, times by 3, it creates a bit like what we had before. Okay, I'll just put the 3 in front of the brackets, really. So 3 lots of 5x minus 8 is going to equal 3 lots of 6 minus x. You could be lazy and just say, we're all done there and then finished. Which technically is right. We've times both sides by 3. It's just not in expanded form. If we want to use that expanding stuff we were doing recently, 3 times 5x will give me 15x. 3 times minus 8 will give me minus 24. Okay, I've just got rid of the brackets. 3 times 6 will give me 18. And 3 times minus x will give me minus 3x. And that's your lot. So with an equation, okay, what we're looking for is got the equal sign, got a letter, but only one letter appearing in it. And anything you do to the left, you must do to the right. Okay, we'll have some questions a bit like this, all right, on the your turn questions. And I'll see you on Wednesday. Take care. Be safe.